Okay, good morning. Since we are already here, so we start early and then we end early. Um, so for today, we're going to talk about some of the geospatial data format, um, traditional vector raster data format, and then we get into some of the cloud format, basically Google's engine or some other type of cloud computing, how they store geospatial data. And so there will be no coding today, but after today, make sure that you get a Google Sensing account. So how many have you already get an account? If you haven't, then just Google Sensing. Like I said, upper right corner, get started, and then sign up using your personal Gmail account. Don't use your UTK because you might not be able to create cloud project. In the past, it was okay, but now university restricted students from creating Google Cloud project by themselves. Uh, Creating a project is free, but the project can be associated with other services, and you might accidentally use other stuff, cloud computing that we charge money. The university doesn't want to pay. So use your own account. You need to enter your credit card, but it's free. But don't mess up with other cloud stuff. Okay, so you don't be surprised with your bills at the end of the month. But Google saying is totally free for research and education. So get an account after today. Otherwise, you won't be able to follow starting from next week. Okay, so get started and then just fill in the information. If they have changed some of the application, but if there's a box that you can enter no, you can say you are taking course with me, and they will recognize me. So if they need to approve, it will be faster. All good. And so for today, we want to talk about format, and you can take a look at the schedule. So we're going to follow the schedule, but sometimes might be faster, time might be lower. It's fine. So today we're going to talk about spatial data models. Essentially, just data formats, right? So this course is about spatial data management. It's just like you are managing files, right? So we need to talk about some of the commonly used formats. And so if you already used GIS before, can you name some of the data format that you have used before? For example, what are the commonly used vector data formats that you have used before or you heard about? That's like geometry. I'm talking about like file extension, for example. What kind of file format represent the file? Yeah, one. Yeah, XML. Yeah, it counts. XML is not. XML is like a markup language. There's another one like you based on top of XML. KML, KMG, right? Google Earth use KML, KMG, so those are the vector format. Anything else? Any other vector data format that you are familiar with? Yeah, exactly. GeoJSON, like plain text file, is GeoJSON is also vector data format. Anything else? There might be some. Okay, I will show you later. But these are the three common ones. So for example, GeoJSON, step file, KML, KMG, right? Some of the vector for the formats. What are the raster data formats they commonly use? TIFF files, right? Anything else? Yeah, PIX, like PCI Geomatica. Yeah, PIX was also used before. Anything else? IMG, yeah, IMG, yeah, IMG. That's imaging, so it's also JPG is a format, but it's technically not really geospatial because it doesn't have geo reference. So when you talk about geospatial, when you open it in desktop GS, it needs to be somehow overlaid on top of the basically on the correct location. Otherwise, there's no geo reference, and then you'll be just a regular JPEG, PNG, G file. Those are not geospatial. So we're specifically talking about most commonly used right nowadays would be Geotif. Cloud or cloud optimized Geotif is still a Geotif. So we're going to use some of those in the following weeks. And then IMG is also quite common. Those are the, I mean, traditionally raster and vector data format. Besides that, are there any other data format or file extension that you use for geospatial? What are some of the file format that can actually basically store the file vector and raster inside them? No, that one is just for doing coding. I'm talking about, like, for example, if you have a local file, you want to manage the file. What some of the things you might be using? Say it again. Exactly. Geo Database, GTB. So that's for Esri products. Are there any other open source alternative data format that you have used before? Like, database is actually when you have a lot of files, not just put all the files in a directory. In the enterprise solutions, you will need to have some kind of database actually to manage the file, and it's very efficient, very powerful. And this is the second half of the semester that we're going to use PostgreSQL and also PostGIS. So those are the database actually managing the raster and vector files. So GeoDatabase is one of those. Anything else? GeoPackage, exactly. So GeoPackage is more like the open source solution, widely used by QGIS and some other packages. So GeoPackage inside, you can have vector, you can have raster. It's also very powerful. So we will talk about some of those in the coming weeks. So here under the Google Drive in the directory, I actually put 2 files in here. So although it's lectures, it's just maybe something for you to read if you need more information. But if you open it, this is quite a nice blog published on GS Geography. Show you the list of all the file formats. Vector data, for example, we talk about shape files, GeoJSON, and so those my computer is frozen. Okay, so shape file, GeoJSON, and then GML is not as common as KML and KMG. And then you have some other, for example, GPS coordinates, EGC used to be MacInfo, but these companies nowadays are not. Have you heard about MacInfo? It used to be when I started doing GIS, it was like MacInfo, Esri, and some others, but now Esri basically it's become the dominant player in GIS. And some OSM, okay, OpenStreetMap data. If you go online, if you see something .osm, those are also vector data. We don't use that in this class, but just let you know it's out there. And ArcInfo coverage. This was in the early days, but it's not commonly used right now. So those are the commonly vector data format. Raster vector is basically GeoJSON and shapefile, but the most common one. Raster data format, most common one is basically TIFF file, Geotif, and also cloud optimized Geotif. We will talk about that in the coming weeks about cloud optimized Geotif. Why do we use cloud optimized Geotif? Think about when you're streaming data from the cloud, just like you're watching a movie. Right? If you store it on a local computer, it might be MP4, MKV, AVI, that kind of format. But when you're watching movie in the cloud, it doesn't actually download the entire file to your computer. It actually requests a small section of the movie. Think about here, when you like use the time slider, you switch the location, it may take a couple seconds to buffering, and then you do watch the movie. So this is basically based on request, sometimes called HTTP request. Just like you're looking at Google Map, right? Or Google Earth. It doesn't download the entire archive to your computer. It's based on your location when you zoom in, based on your zoom level, based on your extent. If you're only looking at the entire globe, the resolution is very coarse, it's very low resolution. So it's basically subdivide the area into smaller pieces and then download all the pieces, and then just under your computer you will have like small tiles, each like one tile for each location, and then put it all together. Looks like seamless, but it's not. So this is basically all the cloud computing nowadays like that. We are streaming the data. We are only downloading the data based on the area and based on the zoom level. And this is very important to understand. Otherwise, if you might having difficulty understanding like why it is so fast, why the compute is so fast. You're doing at the global scale. It's actually not doing, for example, even if you have 10-meter resolution global scale, it's only doing like 10 kilometers, and they do it really fast because it's sent to tens of thousands servers, and one server is handling one small piece of the data and do the computation, get the result, and then display on the map. It's a seamless map. Looks like seamless, but it's coming from tens of thousands of servers. So this kind of the general idea behind those cloud computing, especially Google's engine we're going to talk about. So Geotif is the most common one that we're going to deal with. And IMG, you might also see this one, but it's not very common because these are mostly for commercial using the ERDAS imaging software. So Geotif and the PIX format, also another company, and Esri Grid. In the old days, you use Esri Grid, but now you can also use Geo Database and you can create a raster. So you don't actually have to deal with the data format. All you need is just a Geo Database. Inside there, you can put raster data, vector data, feature classes, raster dataset, a bunch of those. We might use some of those in the future, but just to give you some of the basics about data formats. And there are a couple more here. This is more like compressed, mostly for raster dataset. Any of you have used this before? JP2, ECW, and Mr. Seed. And these are all, I think they're not free. At least I know Mr. Seed and JP2000. So basically, you need a license to be able to use those. In the early days, ArcGIS products use this, but now they have their own Geo database and raster, so they don't use this anymore because you need to buy the license to be able to use that. But the nice thing about this is it compressed the data very well, and it preserve the resolution also very well. So think about most of the ratio is 20 to 1. So basically means if your image is 20 gigabyte, and then if you save in this format, it's only 1 gigabyte, but the resolution is still pretty good. So but again, it's not free. So nowadays you won't use this very often, but if you see that online, sometimes you download the data, you might see this one. For example, some of the data set from the USDA NAM imagery, National Agricultural Imagery Program. In the past, they also used meter seed because think about if you have one resolution covering the entire US, the data set are huge. So you need to some way to store the data efficiently, and if you can compress, and then when you open the data, it still look as good as the original one. Why not, right? So if you can, for example, you can have $20 to buy something. You can also use $1 to buy similar thing, very very close, but it's only a tiny quality difference. You probably don't want to pay $20, right? So this is like why compress is very important, especially for geospatial data, raster data. Compress is very important. So Geotif right now can also compress very well. You have different mechanisms. So we talk about some of those in the future, but like I said, for raster, all we need is this one. You can use both locally. You can also use in the cloud. You can also stream the data from the cloud. That's why it's called cloud optimized Geotif, because you don't download the entire file. You only request based on the region, based on the zoom level, and it's really, really fast. So this is basically so-called cloud native format. We talk about some of those in the future. So just to let you aware of this format, and then Geo Database. Okay, so GDB is the one by Esri. So this one is not open source, but you can store data very efficiently. It also have something you can compress. So if you use Esri products, definitely you're going to encounter GDB all the time. In the early days, it's called MDB, Personal Geo Database. Probably 15 years ago when I started doing GIS, this one is very popular, and it's based on Microsoft Access. So if you heard about that, like it's also a database products, but the limitation is this one only can store 2 gigabyte, maximum 2 gigabyte. So if you have large data set than that, you cannot use it. And nowadays, most of the big data you handle is going to be hundreds of gigabyte, terabyte. So it's not going to fit into this one. Geo database, this one can work pretty well. So and there's another one here, Geo package. This is the one using mostly open source, QGIS, You might use some other programming. So this one, inside there, you can put vector data, you can put raster data. Okay, but one thing to keep in mind, inside the database, there's no file extension. Okay, so you can import GeoJSON into the GPKG, into the Azure database. You can import raster Geotif into the database. Once you inside the database, it's not a GeoJSON. It's not a set file anymore. It's just vector data. Okay, so if you open the file, for example, in Azure product, it's a directory, and then inside there, it is just like bunch of random character files. You don't see like .geojson, you don't see .ssp, because it's no longer a standalone file format. So just to keep it in mind. And there are some other format, for example, MB tiles. Essentially, those are the file format that it's a database, it store data in there, and it's served for different purposes. Some like for the cloud, you can stream the data in the cloud. Some more like just database you can handle, you can use for other desktop GIS. So, and then we have some enterprise database, relational database, and this is the one we're going to cover during the second half of the semester, PostgreSQL and PostGIS. So basically, you can install that on your local computer. You can build a database, but you can also do it at scale. So lot of tech companies, they actually use this one because it's free, it's open source, and you can handle petabyte of data and still has high performance. But if you're doing locally, if you have like hundreds of gigabyte of data, it's not going to be able to handle that. But you can store the data, you can also query the data, you can do it really fast. So this is a very important technology in the industry. We will cover that. In the past, they also ArcGIS ID, but it's not quite commonly used nowadays. So don't have to worry about this. And then there's some LiDAR data format. So LiDAR, basically, the LiDAR data format will be mostly point cloud. We will not cover this one in class, but just to be aware, like .last format, .lag, originally was called last, and then so LAG is the compressed format of the point cloud. LiDAR data is usually pretty big, so it's like millions of points, and just XYZ, and then you can use to do 3D construction, and you might also see XYZ again, but we'll not cover this in class. Just so you know, those are the commonly used data formats in GIS. And then there's AutoCAD format. If you use AutoCAD, these are some of the formats that mostly used in urban planning, in some planning department. You might use this data format, and then you can convert this to Azure or other vector data format. Okay, and they have some elevation, DEM. Those are the raster data formats. But nowadays, most of the government agencies, most of the data portals are using .tif, Geotif, and then most of the data have been converted to cloud optimized Geotif. That means when you need the data, you don't need to download the entire data set. You're just requesting a small piece. So for example, in the future, all the Landsat satellite data will be using cloud optimized Geotif. It's not DM anymore. It's not IMG anymore, because only that format support requesting based on your request, based on the UI, the region, based on the zoom level. So it's so much faster. Other data set, you have to download the entire one. So like I mentioned in the first lecture on Wednesday, right? Landsat 9. I don't know, Landsat 10 on right now it's called Landsat Next. So it's going to be 20 gigabyte for one small tile, and you don't want to download 20 gigabytes. It's going to take you hours to download if you have slow internet. But if you use the cloud optimized Geotif, you can say, I want this piece, I want this small area, you request it, you get it instantly, right? Of course, if you want the entire data set, then you still eventually have to download. But most of the time, you're just doing visualization, you don't need the entire data set. Or you can do the entire, you need the entire area, but you don't need the full resolution. You don't need the 10 meter. So when you zoom out, it's probably like 1 kilometer resolution. Still, the file size is pretty small, so it can get very quickly. Internally, basically for the Geotif, they have the so-called pyramid. So you have the full resolution, and then it's going to resample to like 2 by 2. So basically you have a pyramid like this, the full resolution, and then coarse resolution, coarse resolution, coarse resolution, until you get to like just one small tile. Understand? So it's really fast. So this is very important technology we're dealing with the cloud and some of the other formats in here, but most essential is the cloud optimized Geotif and some of the commonly used vector data format. We will cover those later this course to show you how to handle those data format. You can use desktop GIS or can use programming. And then when we get to Google Engine, then you can forget about all the data format. It's just the cloud. There's no vector. There's some terms like feature collection, image collection, image, but it's not GeoJSON. It's not Spatial. It's not Geotif. It's called cloud format, and you don't see the file extension because you never really see where it is stored. It's somewhere in the cloud. You know it's there. You get the ID. That's it. Right. So think about each of you. Right. You have your driver license or your social security number. All I need is your social security number. I don't need to know where you are, whether you are in Tennessee or in California. I don't care. Of course, when you're accessing the data, the closer you are to the server, the faster. But most of the time, all I need to know is what you can do. That's it. So if I just say, okay, I want some elevation data. I know that, okay, you are SRTM. I know your ID. Give me the data for this area. That's it. And I don't need to know, oh, are you Geotif or are you ODAS imaging format? I don't care. Oh, are you just set file format or GeoJSON? No, I don't need to. I know your vector data, your feature collection. Give me some data give me all the buildings for Knoxville or for the entire US. And it doesn't matter your area, how big is your area. It doesn't matter the resolution. It'll be the same. It's really, really fast. So everything can be pretty much do very efficiently just with a couple lines code. So this is the next generation of doing data management and doing things in the cloud. So those are some of the basic concepts I want you to be familiar before you get into the cloud. Otherwise, you don't know the foundation. Where does it come from? Like why we use the cloud? Because that's the way it's going. In the future, you're not going to be able to just handle things in the cloud. And I don't think people go back to watch movie on the DVD, Blu-ray, and then you have to have a computer, you have to have the device to play it. All you need is just a browser. That's it. And you can do it using a phone, using a tablet, using a laptop. You can do it anywhere. This is making things really accessible and reproducible. If you do something, other people can do the same thing. Think about if you're doing a project. You're opening ArcGIS, you're opening the data, you do some selection, you do this and do that. If it wants other people to replicate the result, you need to write down the exact step, right? Otherwise, how? Because everyone is going to do things in different sequence. You're going to get different results. But the cloud computing, everything is this. If you have the code, if you run, you should get the same result. So this is like the new way of doing research. Okay, so that's what I want to cover. Of course, you can read through that and you can come back as a reference. And the other one is the Geo Database. We don't use that a whole lot in this here. We might use some GPKG, but mostly in the cloud and PostgreSQL. But there's also inside the Geo Database. Basically, inside there you have feature classes, basically vector. So this is within the database. So feature classes basically means you have a feature class. Within there, you can have points, lines, and points. Basically, you can have multiple layer of vector data, and then it's all under the feature class. So basically, if they share, think about here, you can create a database to store data for Knoxville, right? And then within the database, I can have a feature class for storing vector data. So inside there, I can store, for example, building footprints, or just points, or the restaurants, just as a point within the feature classes. I can have all the rows as another feature class within as another feature. It's called feature. So basically, when you have something share something in common, you can put them under a feature class. And then you can, no, feature class is individual, but you can have what's they called, feature data set or something else. So you can have something on top of that. So basically, it's a hierarchy. So database, and then you have some like data format, and then within there you can have different features under the class similar to the raster dataset. You can have, for example, raster dataset. You can have one image for DM, for temperature, or for something else. So basically, it's like two hierarchy. Just like here, university, departments, classes. Different classes, for example, in GOG, right? Geo 414, 411, it belongs to geography, right? And you might have computer science, you might have different classes. So the database is using a similar technology. You have a hierarchy within under the second level is more like the organization, and then within there you can have individual. Okay, so database is also very important. We talk about some of those when we get into PostgreSQL. But these are some of the things you can read, and there are tons of documentation on the internet. You just Google Geo Database or Geospatial database, you will be finding a lot of things to read. Yeah. Okay, so this is the desktop or traditional way, traditional data format. And then, so next I'm gonna quickly go to the cloud. So give you a brief introduction into Google Engine. So Google Engine basically is a cloud computing environment, can process so-called petabyte of data at scale. So we can do things really fast. Basically, you can stream the data to your client, to your browser. You can also run computation in the cloud really fast. We talk about those in the next couple of weeks, how you can actually access the data and also analyze the data. And like I said, is think about the Netflix of Geospatial. Right? It has tons of data in there. Just like you can go online, you can source any data set you like. You can go on Netflix. You can source any movie you like. You just watch, right? But besides that, think about what else do you need, right? Besides watching, besides visualizing the data, you might want to analyze the data. For example, in a movie, you might want to analyze who is the main character in that movie, right? If you watch a long time, you know. If you don't have read the description, if you don't read the movie description, you probably have no idea who is the main character until you watch for a long time or a while in the movie, right? So similarly, in Geospatial, you can calculate all kind of statistics or analyze the data. For example, how long does the character appear in the movie, right? For how many times, for how long, right? And in what specific timestamp, you can grab all the information. So similar to the cloud, you can do that very easily, and you can do all kind of calculation and get the result, and can also visualize the result. So for those of you who have not used this before, again, sign up for an account and you can read the description. Think about Google Engine has three components here. So you can have data, and then you have the API to run the API to basically do the computation. And last one here, you can also create web apps, interactive web apps that allow people to access your data products. So you can think about data, compute, and a platform for you to share your stuff. Okay. And next, let's talk about the data here. I just want to show you because data, basically you need the data to actually to be able to do something. So Google Engine has a public data catalog right now. I think it's over 90 petabyte. Okay, so 90,000 terabyte of data. Not everyone can actually handle this kind of data set. Even for large corporations, it's still a huge amount of data. So how big is your hard drive right now? For most of you, 1 terabyte? 2 TB, right? 2 TB. So think about here. 90,000 terabyte. So 90,000. So you need like 45,000 computers to store. And not just think about not just the storage. Storage is actually easy. Compute is also more intensive. So how to actually process those data is huge. But next time, if you need any geospatial data, come here to search it. You probably will find something here. The nice thing about this is that you don't need to download the data. You can actually visualize the data directly in the cloud. And let me give you an analogy, right? So right now, basically, okay, I want to watch a movie. I want to watch what movie do you like? Frozen. Okay. Yeah. Okay. Frozen. Right. So in the past, like think about right now, you want to watch that movie, and if you go, there's different ways you can do it. You can go to buy the DVD, and then you can take some time to get there, and then they have computer. You need to have a DVD ROM to play it, or you can go online somewhere to download the entire movie to a computer, but you cannot preview. You need to download it before you can actually see it. Okay, so they say it's two gigabyte. Download to your computer. It's going to take maybe 10-20 minutes. Or do you want something that you click and then you can see it, right? Probably you don't want to download entire movie. So this is like this. In the past, if you need some geospatial data, you need to go to NASA, go to USGS. You need to grab the data and then download it. NASA, USGS might have some data portal allow you to see like just a thumbnail, a small low resolution imagery. That's it. But you cannot zoom in, you cannot zoom out. You cannot actually see it. But this one you can. All you need is just to figure out what's the ID to the image. And then you can load the map, you can zoom in, you can inspect, you can do all kinds of things. And you didn't need to download anything. So this is the power of using the cloud, is that you can visualize data on demand without having to download the entire data set, right? So you can visualize 80 petabyte of data, any data set within the catalog you want without having to download anything. So here, for example, surface temperature, climate, atmospheric weather imagery. Probably the most common one here, Landsat, Sentinel, or even high resolution here. For example, if you click in, you will be able to see a subset different data set. So in the US, the National Agriculture Imagery Program, this is the best one. So this is like 1 meter resolution for the entire US every 2 to 3 years. So if you know how this is still underutilized, this is a huge data set. This one is like, I'm not sure how many terabyte or even petabyte of data. And it's very useful because it's free and you don't get this for other locations around the world. So think about here, okay, I want to do something. I want to get some high resolution imagery so they can see the changes. You can do the search, and then if you find the data set, you can do the description. You can see how many bands, spectral bands within the imagery. So this one has RGBN, so N means near infrared, right? And you can see the citation, where does it come from. Then all you need is just click this one, open in co-editor, and then log into your account, and then you can see the imagery. But you need to figure out what area do you want, what location do you want, and then so this is basically the sample code. We covered it more next week, but take a look. See, 1 meter resolution. This is for like New York. Think about, if you see me zoom out, take a look. Do you see the boxes? The each time. You see. So the cloud, when you zoom out, or zoom in or zoom out, is requesting based on the type. But it's not downloading the original data. Everything has been converted to the cloud format. So if you do it really fast, if your internet is not fast enough, you're going to see a lag, and then it's going to request the data you see here. Right? So every time it's actually downloading those smaller pieces onto the computer. Your computer actually is just rendering the smaller pieces that went in here. But this is really high resolution. You can see cars, you can see buildings, and it's all free. And I don't have to download anything, right? In the past, before this is available, you need to figure out, where is my location? How do I figure out what image is actually intersecting this location? And you also need to figure out what time do you need. It's all very difficult. Now this is like anywhere. You can do it any location. So I'm not sure if you can, let me zoom out, zoom in a little bit here, right? Image collection. So this is basically the ID. So basically the unique ID to this entire data set. And then within there, I can say, okay, filter the data. I just want the data from 2017 to 2018, within those 2-year time period. And then I want to select just the RGB. Okay, you can change it. This is just the natural color, and then this is how I'm going to visualize that. And this is where the location I want to visualize, like longitude, latitude, and then the zoom level, and then just add the data layer to the map, right? Think about here, it's pretty straightforward. And You can do that anywhere. It doesn't have to be New York, right? For example, let's say let's look at Knoxville. Of course, you can just zoom out all the way and then find out to go back to here, right? And then when you zoom in, it's going to render. You see? Where are we? Somewhere here. Look at this. Right? Not bad, right? And you can download it. So all the data inside the cloud. Originally, those data in the cloud optimized Geotif, and then Google ingests the data into their data catalog. It becomes some cloud format optimized, and now you can just stream the data. So think about if you are having the ability to watch any movie you like for free, anything. And if the movie is not available, for example, okay, you take some photo movie, you produce some movie by yourself, and then or even your phone, you can also utilize it. You can share with other people. All you need, just upload your movie to your account. Here, you have some assets in here. You can upload it, and then you can also load the data into the interface. And then you can stream the data. You can also share with other people. And it's very, very powerful. And you can also do the visualization here, for example. Okay. And you can change the color if you want. I can change it. For example, this is just RGB. But they say, okay, I'm doing some vegetation studies. I want to study vegetation, right? So most likely you want to deal with near infrared band, right? So all I need to do, just come here. Okay, I want to do vegetation here, and then maybe red band, and then green band. So Google says it doesn't have the interface like ArcGIS for you to like open the property and then just change the band combination. No, everything will need to be done using the JavaScript code or using the Python. But as long as you know how to do that, it's very precise. Very precise. You get exactly what you want. And also here, right? So right now, for example, they say I want this area. I want the map when I run it, it's going to automatically center around this area. So all I need is come here, and then I grab the inspector. You click on the map. See, you can get the location. You can also get the band value. So basically, the inspector allow you to inspect the pixel values, and then I can just simply grab this one. This is location of this building, and then I run this one. Right, just hit run. See, hit again. Yeah, so we can change it. Okay, so if you want a high zoom level, I can change it to 18. You run again, whoops, and run again, control enter. See? And you can change it to whatever combination you want. You don't have to redownload data. And all of a sudden, okay, your board, your advisor asks you to do Knoxville. And then next week, okay, I want you to do San Francisco. I want you to do Austin, Texas. In the past, you have to go online just to figure out the same procedure. You need to download data. Now you don't. You just any way you like. And for example, they say Nashville, right? Okay. The data actually already at the national scale, but you can certainly filter it. And for example, I just want to look at this area. So when you figure out the area, I can just click and get the location. Copy again. And then place. Find it. Oh, yeah, good point. So I forgot this one here. Zoom, yeah. And you can change the zoom level, change the location. It's really easy. Think about it's not just for visualizing data. This is just the first step. You can analyze the data. You can extract the vegetation. You can extract the buildings. You can extract water. You can do anything you like. So traditional remote sensing, most of the things are already supported here. But this just give you an idea how you actually access data, how you search movie, how you watch movie. But how do you analyze what's inside the movie is another step. But right now, at least you can do whatever you want. You don't have to download data. You can do it anywhere. You can also search data directly in here. For example, they say, okay, I want a DM. Just search DM, and then you can look at some of the data set in here. Also vector data. For example, 3 depths, right? 10-meter resolution. All I need is import and take a look. It's inside here. Oops, no, not this one. I think it's the other one. So I think need to maybe this here. Three tab. Okay, it's basically the resolution. So for example, 1 meter, 10-meter table here. This one, seamless, for example, 10-meter resolution for the entire US. Okay, and it's an image. This is ID. And now let me show you how you can actually add that. So I can do it here. Map.add layer image. That's it. Control enter. See? Of course, it doesn't look good because it's all white color. Why it's all white color? We haven't covered this yet, but just let you know, just like inside, if you open the image in ArcGIS or whatever, in sometimes by default it's going to be from 0 to 255. All the elevation pretty much are above that, so it's you don't really see anything. So you can set, for example, I can do minimum 0 and then comma maximum maybe 4,000, for example. It should be much better. Yeah, you can also change the let me uncheck this one. You see, it's better now because this is what the elevation. But you can change the color. We talk about that in the future. It's actually pretty easy. Just one line of code, especially by using Python. But this is everything you can make adjustment. For example, I just want to display any elevation between maybe 500, oops, to maybe a lower number, 3,000. What do you expect to see the image? How is it going to change the color or the brightness? Yeah, a little bit more bright because you lower the value. So anything above 3,000 you'll be white color. Anything below 500 you'll be dark color. So basically it's shrinking the range. That means it's going to actually make a little bit more bright. Not technically, the darker area will still be dark because it's below, anything below 500 will be very, very dark. Anything above 3,000 will be, oops, will be all bright. So if you want it, before we need to zoom out, you can change the zoom level to just a smaller number. It should render quickly. And again, let me turn out this one. It's gonna take some time. So think about the image is an entire image. Is I'm not sure how many gigabyte. It's like gigabyte data. So 10-meter resolution is actually pretty high, and you see the loading bar here, but it should not take this long. Okay, it's coming out. Anyway, so this is how you can actually source the data, load the data, and then just visualize the data. And then you can start doing, for example, extracting the vegetation or whatever. You can combine different data layers all together. So it's very, very powerful. And right now, he's the dominant cloud computing platform in Geospatial. So we spend more time covering this in the next couple of weeks. So that's basically the data set, and just explore it, click in, search any data set you like. Even for Landsat here, if I click here, you see Landsat 9, 8, 10, 7, 5, all the way to Landsat 1. If you click Landsat 9, inside there, they also have different data products. Surface reflectance, top of atmosphere, and all the data set within Google Engine is basically has a unique ID. So for this one here, specifically Landsat 9, you see here image collection, and then the Landsat sensor, the ID of the number, collection to different processing level. So this is basically ID. Image collection basically means it's a bunch of images under a folder. So think about, you have a directory on your computer, you export a bunch of files, you go image collection. Sometimes if this image, not sure why it's still loading, but here we click this one, So this is image collection, DOQQ, but you also have this one here called just image. We cover that next week when we get into Python dealing with Google Engine. But basically, it's image collection, feature collection. So that's the basic data format in Google Engine. So similar to the traditional vector data format, for example, a swap file is a feature collection. Within a swap file, you have different geometries, different features. You also have a table attributes associated with the geometry. So feature is basically has a geometry, also has the attribute. A feature collection basically equivalent to a swap file. So think about it here. Image is equivalent to Geotif, a Geotif. Image collection is equivalent to a bunch of Geotif. And then, but you can basically do all kind of filtering. For example, let's say you use a cell phone, you took a bunch of photos throughout the year. You can select, for example, I only want the images during the summer. I only want the images during a specific time period at a specific location. Inside there, you can do all the filtering. Very easy and it's very fast. And again, we'll talk about more later. So this is basically the data set you can get into there, and then the platform. So most of the time, you might, if you want to use JavaScript, it will be the code editor. So the code editor is this one. So basically it's here that what we're using. You can write JavaScript code in here. On the left side, you can store your script. So for example, I can save this one. I can save to my account. Kind of similar to Google Drive, basically. You can store all bunch of files under your Google Drive. And then next time you can open it, you don't have to recreate one. But you can always just open an empty script, and then you can start writing. And then here, all the documentation. And this is also useful if you need to search something. For example, they say, okay, I have the imagery. Right now, I want to maybe clip, for example. I have the global national imagery. I just want the imagery for Tennessee. Right? In Geospatial is some kind of extract by a mass or maybe clip, something like that. So here I can just maybe search. I'm not sure if this is right or not, but if I search clip, right? There's a function called clip. And then within there, you can see the documentation, right? Something clip image, dot clip, and then passing to a geometry, and then you can clip. Again, we'll talk about more of this in the future, but just to let you know, you can search anything you like. For example, you can median. You can create a median filter to create a cloud-free imagery, right? 3D is just a median. So think about here, you have a million images. I want to create a cloud-free based on these million images. It's just one line. That's it. You don't need to like download a million images. One line of code can help you do that easily. And this is the documentation and also the assets. This is where you store your files, store your scripts, and all you need just click here, run, and then you can get the result instantly. Also, the get link. Get link means it basically similar to Google Drive. You share the file with other people. So you send the link to other people that has the Google Engine account. When they open it, they will see the same stuff. And then you can easily make things reproducible because anyone use the same script, we get the same result. And you don't have to describe to them like, oh, you need to open, click this button, click that button, open the file, select the, no. It's just a link, open, run, result. That's it. So this is something also very popular in the academia now. That after you do something, you want to share with other people how you did it. If you can reproduce everything in here, perfect, then you can do that easily. And here are some of the more tools that you can use. And this is just a brief introduction to JavaScript, but starting from next week, we just talk about Python. And you don't need to know JavaScript. You can do everything within in Python and have similar experiences to the JavaScript. So you don't have to worry about that, but it's still nice to be able to know some basics, because every time when you, for example, if you look at this data set, you can open in code editor, and then you can open in the JavaScript editor and then just run. Python does not have that one yet, but hopefully soon you will be able to do that, because I've been working with Google Sensing to basically in the next 2 to 3 months, GMap will be officially on the documentation. So you're going to have equivalent documentation besides JavaScript. So for example, here right now, if I quickly show you, if you go to documentation and then click here and get started. And so for example, you can go to any documentation you like, right? On the left side, visualization. And in the past, mostly just JavaScript, but now you also have equivalent Colab. Basically, we're going to use Colab also in this class, but this allows you to do things in Python. But right now, there's no button for you to open yet. And this is also not using Gmap, but very soon, you'll be gmap.map or something like that. So everything that you learn in class, some of those will appear in the official documentation. So hopefully sometime before October, but I will let you know when it's there. So just to let you know, you can just do things in Python without having to know JavaScript. But because JavaScript has rich documentation, so you can get a lot of help from the documentation. Python is improving, but it's not there yet, but there's a high demand. People want to do that, okay? And we're out of time, so today is just a brief introduction. And what you need is get an account, and starting next week, we start doing fun stuff, okay? See you next week.